programs and write, that is secondary. But we should know how to solve programs. Now, how to find a factor, all the factors of a given number. Generally, what we do, if this is the number, we're not thinking about program way, we're not thinking about a program. How to solve mathematically, how to find out all the factors of number 12. So, what is the lowest factor and what is the highest factor of any number? Even if I don't know anything, what is the lowest factor of any number, any given number?
1.
What is the largest factor of a given number?
The number itself.
Now, how will you find out which are the numbers which are called as factors of the given number? That means now we have to follow all the numbers. We have to check that. We don't know right now. Starting from the number till, from the 1 till the number. Now, how will you find out which number is a factor? Should I check from 1 onwards and including number? Should I check is it a factor or should we leave these two numbers?
Leave them.
Yes. And what about the others? Is it a factor or not? How will you find? Is it a factor or not? How will you find? Of whatever the number may be.
You should divide with each number and see if you get a reminder.
The procedure is only the same procedure we have, right? We have to just go for the division with the number and just check if it's divisible. If it's giving 0. So the checking procedure is divisibility test with that each number starting from 2 onwards. Till which number? Till less than 10. Because number itself is a factor. How we know. So all the numbers which are perfectly divisible, we should print. Now come back to the programmatic way. So how will we print each factor? Is it one factor or all the factors?
All the factors.
So should I use a loop or we should not use?
Loop.
So loop is used. And what is required, minimum requirement of a loop? What we should type for every looping concept? What are the steps of the loops?
Initialize.
Test expression, the statements, and increment or decrement. So in this case, the loop starts from which number?
One.
It is started from 1. Okay. But efficient program, I'll see. What is the best program? We'll see it anytime. And till when? What will be the last limit of it? That means test expression should have which criteria? What should be the criteria in this condition? Okay.
Till it reaches the number.
Yeah, that means I have to repeatedly check all the numbers which are less than the number itself, less than or equal to. That means whatever count or whatever we can put for operation, I'm checking all, right? And what should we do exactly inside the loop? What should be the repetitive logic?
I plus plus.
Before I plus plus. Okay, this is I plus plus. Increment or decrement is just I plus plus. What is the statement or the logic? We're going to what we should do on every number, what should we talk?
Num percentile.
So num percentile of I. If it is 0, what should we do?
We should print it.
Yeah, that's it. If it's there, we should just print that I. So that means we have to start the loop starting from which number? Just to print all the factors of a given number, I'll take an initialization variable of 0. and int the given number. You can accept from the user. So you can accept the value from keyboard. Now expecting that the loop should start from which number right now. If I only declared it here so that I can clearly see all the three instructions. It starts from 1, I less than or equal to number and I plus plus. What we have to print every time here, which all numbers? So which numbers have to
I
print? If
num modulus I
I, whatever the zero, just only one we have to print because all are not factors. Only the factors should be printed. Till here it's clear. Now the next program, like if I have to find the sum of unnatural numbers, how will we do? If I give you some natural numbers, these are 5 natural numbers. I said, please find the sum of them and give the answer. How will you start addition? Not the program. Addition procedure, how will you start? Addition will start with two numbers. No? We cannot add just one. Every time we'll add two numbers. So I may go from top to bottom in addition, or I may go from bottom to top. Anything is fine. Now, in addition, which numbers we are adding first? We are getting the answer here as
3.
and then this answer we are taking. So here it is 3. So we are taking this 3 answer and again adding with which number? The next available. That means that 3 plus the next number is 3. That means again the answer is 6. So I am always adding the answer and the new number. Just check from the beginning. If you repeat here, first what did we do here? First which two numbers we have added? And we got some answer. Second time what did we do? Second time which
New
numbers
number
we
and the other one.
yeah, new, that means the answer. Previous answer plus the okay. The new number or this is the answer let us pick and this is the new number. The answer is 6. And again here the previous answer and the new number. I'm just writing in this order. These are the numbers right. Continues. So this is the sum of how many natural numbers? 5 natural numbers. So I'll go to which number? Till the 5th number. So I'll get the final answer as 5 and we'll start. When you see this addition, we are repeating something here. Every time we have some similar steps. What is the first number and what is the second number? How did we get this? What is the first one in this addition and what is the second one in this addition? You have to make it like a formula. You're getting a result. This is of course a result.
Sum and
This is a result. I mean this last one is a result. How did we find this result? By adding which two numbers? Okay, check here. Leave the first line. Check this one. This line, how did we get the result?
result and the number after it.
Yeah, that means previous result. Already we had a result, previous result, plus some count.
Number.
Some count or some iterative value. Okay, so that is it's going from 1 to 5. We can see that 1, 2, 3, 4, 5 we have seen, but only one is missing in this scenario. One is missing. Rest all we have seen in the line 2, 3, 4, 5. These numbers are added with which number? Some result. So that means we can take initially also some addition. So I'm taking here the initial calculation as 0 plus 1 and this is becomes as 1. Now it is a complete it is the addition procedure right now. So we have added first 0 with a number 1. Iteration started from which number? First natural number that is 1. By this addition of these two numbers we got the result. So initially the result was what right now? Initial result was 0. Just if you see these numbers also, generally when we do the additions, see from top to bottom. Initially we don't have any number. That means initially the answer is 0. Then we add 0 to the first number. That means our total answer becomes 1. Then we add 1 to 2. This becomes 3. This 3 with the next number, 6. So it keeps on repeating like in this way. So we are just adding with some sum right. So initially we have taken some sum, that is a result, which is initially with which value? What is the value of the result? 0. And what are we going to add to this number every time?
The next number.
Yeah, the value starting from 1 to 5. That means we'll set the values of I. So every time we are adding a result to a new number. The number starting from where? 1 till 5. Result plus the number. Result plus the number. But this addition we are saving again in which variable? This is the result. Finally, this is the addition of the two. So we are trying to just update the result every time by adding the older result plus the number. Right? This is like a formula for this. And the iteration value starts from which number? 1 less than or equal to the natural number 5, and we are going for each of the three. So the loop starts from 1 till the number. Till the number, we are including the number also. And what we are going to do is, in this loop, we are just taking a addition procedure. But before that, we have taken the result as which value? 0. So that it can start initially with which addition? 0 plus 1. This total answer is saved as what? A result. Is that clear right now? We just try to take each number and put it in the result. Result plus the number, result plus the new number, result plus the new number. So this addition is stored in a result variable. Is there any doubt till here? Or is it okay? I think you have done this concept. Why I am asking
Yes,
this
ma'am.
is because based on that, we have to solve the next question. You have a doubt, you can ask me right now. It's only thing we are just taking a result and we are adding all the numbers one after by updating this. Now if I say find the sum of all the factors of the given. So in this question, first you find out how many questions are there. Is it a totally one question or is it made up of two questions? Is it totally one or it can be divided into two parts?
Two questions.
Yeah, so what we can find out? What are the two questions? What are the two questions here? What is the first one and what is the
To
second?
find the factor,
Find the factors.
factors,
And then second is
sum of all the factors.
all. So which one should be done first out of these two?
Find the
The
factors.
Find the
factors.
factors. Now, should I like if I take the number 12 and the factors are 1, 2, 3, 4, 6, and let us say 12. So, should I first take all the factors, then we come back, and then should I do the addition, or can I do both simultaneously? Find the
We can do
factor.
both simultaneously.
Yeah, good. So I need to just traverse once from left to right. Starting from 1 to the number, I'll traverse only once, means one iteration. And in that iteration, what I have to find out first? The factor. If the number is a factor, I should do summing up. That should be summed up in that particular value. Whatever value is there, it should be summed up. And the result should be updated. So now, same thing, we'll go to the next number. If that is also a factor of the 12, I should just add that number also to result. So this procedure goes on till which number? 12. This is the total sum of all the factors of the number. Okay? Now you got the concept here. So how do we convert into a program, right? This one. So how many variables we have here? One is the sum of all the factors of a given number. So how many variables are there in this whole program? How many variables? Yeah, what is the first one?
Number.
And the second one?
I.
Yeah, or factor, anything you can take. And we are assuming that you are accepting number from the user. No value from the user. Okay, so we already got the value somewhere. After that, what should we do? What is the next step?
Should find the factor.
For.
So we have to find every factor starting from which number?
1.
In which number?
Less than or equal to n.
And all the numbers, so I guess.
Plus plus.
Now, what should we do next? In this is the range of the factors, but all are not factors. So what should I do first? How do we get the factors from this range?
If num percentile I is equal to 0.
Now what I should do? Now I found one factor. What I want to do with that?
Print and add.
No printing. I don't want to. What I want to do is find the sum of the factors. I'm not interested in viewing the factors. So I just want to get the sum of it. Just like sum is a variable, it's initially 0. Just copy this I value into this one. Copy means add. So it should be just like adding I value. What will happen with that? The 0 plus 1. Total answer is what right now? 1. Next time 2 is also a factor. So we'll add this 2 also to the sum. Previous sum was 1. So I'll add the new factor. So total answer becomes 3. So this we have to repeat in the loop, right? So for that, initially we have taken the sum value as what? 0. So we have taken the initial sum of all the factors as 0, but we should update it. When will I find the sum of the factors? After finding the factor or before this or after this line?
After that line.
Yeah, so what should we write after this condition? If this is true condition,
Sum plus or equal to I.
that's right. But now if I say find the sum of all the factors other than itself, so what should we do?
I less than num.
As then
Yeah, that's right. So this program has already found out the sum. So at last we can just print the sum of the factors plus the sum. Now I'll add one more sentence in this question. Check if the sum is same as the number itself. If yes, print perfect. Else not a perfect. Okay. We have done step by step already. So to do the last step, definitely we would have finished these two steps. We have already found out the factors and summed up the factors right by now. Now what is the third task left here? Check if the sum is equal to the number itself. If both are same, it's like a perfect number. Just if you take an example of number 6. What are its factors? What are the factors of 6 other than itself? 1.
1, 2, 3.
What is the sum of it? If I take the sum of these, what is the answer? 6. Are they same?
yes.
So sum is 6. So sum is equal to the number itself. So it's a perfect. So we have taken the sum, we have taken the iteration, we have found out the factors, we summed up the factors. Now what is the remaining task right now? Last step. So what should we write at the end of the loop after the loop? After the loop, what should we write now? So I don't want to print the sum also. I'll comment this part. Now I just have to say that the given number is a perfect number or not a perfect. So to take that decision, what should we do?
If sum equal to num,
So this task we have to do it within the loop or after the loop.
after
After the loop.
So if sum is equal to none, just
printf
okay. Else it's not a perfect. Okay. Any confusion till here? That means within the same program we have done three programs. Means whatever is required should be able to do. One program is find the factors of a given number. Second program is find the sum of all the factors. Third program is check whether the given number is a perfect number. So whatever they may ask, you should do accordingly, depending upon the question. Okay? Is that clear? Any confusion?
no ma'am.
No, ma'am.
Now let us say. Now sum of the natural number is clear to you. Sum of the natural numbers.
Yeah.
So how did we do that? Addition from which number? We started the addition procedure from which number?
1.
1 to 5. But if I want, this should be done from this way. Or should we quote it? Means,
Reverse.
yes, how would we? I just gave a number to you. What else you have to do? Just think how many variables involved. We have to guess it right. Previously, how many variables we took when we did 1 to 5? We have taken how many variables?
Sum I
Some
and N.
I and number of three variables. So totally there were three variables. Now check if I do the same program in reverse. In reverse, how many variables are there? So I have to start from where
5.
and stop at which number?
1.
1.
1. 1 is fixed, no? You should stop exactly at 1. Loop starts from which number?
5.
5.
Number itself.
Number itself. So should I initialize it again or is it already initialized?
Already initialized.
Initialized. And what we are supposed to find here? Sum of natural numbers. So I need to take definitely another variable called
I
what we have to find here?
sum
Sum. So I take sum whose value should be initially taken as 0.
0.
Now, do I need to take I or not? Just think and tell. Do I need to take a I variable or not?
No need.
No.
No need, because already we are having the variable for iteration itself. Right? So loop will be written as, how will we write the loop?
5.
How will we write this expression?
Num equals to. We don't have to initialize num.
Yeah, that's good. So it's already initialized. We can keep this blank and put a semicolon. Initialization is done outside the for loop syntax, so don't have to mention. What is the second text expression?
Till num
So
not. We can take not equals to 0.
you can tell. You just tell me, I'll write it. Num
Not equals to 0.
not equal to 0.
Num minus minus.
The minus.
Yeah. Check. Number is 5. Is 5 not equal to 0?
Yes.
Yeah.
Yes. So it's correct. Now 4 also it will be correct. 2, 1, 0. Only it will not do addition at which number? 0. It will stop at 0.
0.
So I can take not equal to 0, or we can take anything is fine, whatever it is. So as you said, not equal to 0. Now what should we do inside here, inside the group?
Sum plus equals to num.
Yeah, concept is same, only the loop condition has changed. Okay, everything is same in the previous program and this program. Now which one is better according to you?
This one,
Yeah, reason?
lesser variables.
Yeah, you have just taken 2 variables. So it is having only 2 variables. So whichever program we can do in reverse order, that is better. Instead of going from 1 to the number, because I will include one more variable. Instead of that, directly we can do countdown. Instead of counters, we can go for the countdown. Right? Let us see, I'll give you one more. Now you know factorial also. What is a factorial? Factorial of 5, if I have to take. What is 5 factorial? It is having
5
which
into 4
calculation?
into
Yeah, that's it. No? So I can go for multiplication from 1 to 5 or 5 to 1. Now, which one
5
you
to
would
1.
prefer right now? Which one you would prefer? 1 to 5 or 5 to 1?
5 to 1.
5 to
Yeah,
1.
5. So how many variables are required?
2.
Yeah,
2.
number, whatever number you can take it. As of now, we have taken 5. Another is fact.
Fact.
What is the initial fact value?
1.
1.
Just take like 1. So 1 into 5. This result into 4. So it goes on. So these are known programs. Sometimes they'll give a new unknown program. And also we should recognize what is repeatedly happening. So what should be the first step? So here it should be initially 1. And what should be the loop? Loop starts from? Loop starts from where?
Equals to 5.
It's of the initial. We can't write it that way. It's been accepted from the user. So I don't know. We accept from the user. So I can't express it manually. Because I said enter the value. So how do the programmer know is it 5 or 10? So num value is accepted from the user. So we don't know what is it. But whatever it is, we'll start from the same value. So initialization is kept blank. Test expression is, as you said previously, num
Less than equal to 1.
Less than or equal to.
Less than 1.
less than is a number less than or equal to 1. Just check is 5 less than 1 or less than 1.
No.
If I write this
Greater
first
than.
time, yeah. So give not equal to or greater than. So not equal to 0 or num greater than or equal to 0. Anything. And num is minus. Right?
Minus.
And what should we do inside this?
Fact into equal to num.
And are we reducing? Yeah. But I cannot bring the number. I cannot say factorial of this number is this. We can't write because number got modified. So number we cannot print. I cannot say the factorial of this number is this answer. So if you want that, we have to take another variable. Otherwise, we can manage it. Because if I say factorial of percentile d is percentile d, and if I say num comma factor, what will be the output on the screen? What is the number current value?
5.
No.
We don't know.
Check. We have done. We have only changed the value of d.
Oh, it's 1.
No. Loop broke at which point?
It will be 0.
Yes. So it would bring that factorial of 0 is 120. So which is a wrong statement. It will come like this. So I cannot take because number is already long. So if you don't want this to get modified, you can take a temporary one and store it if it's required initially. That means after scanning, you can take. Once the user will enter the value, you can initialize that to number. Right? Only if I need this kind of an expression. Otherwise, directly you can take with true variables. So in that way, we can take 1 to 5 or 5 to 1. Both are same. 3 variables. Now, let's we go for the sum of the digits of the number, sum of all digits of the number. How will we do the addition? Same. In how many ways we can do? 1 plus 2 plus 5 or also reverse order. Which one is correct right now? If you get any number, if user has given a number as equal to 125, how will you find the sum of each digit? Where should I start from?
Reverse.
Reverse. So first I need to get 5 out of this. How to get the last digit of a number? I want to get the last
Modulus.
modulus of that means last digit means I want a reminder. Can I say reminder?
Yes.
So which reminder, which division will give you this answer? Last digit of
Modulus. Num percentile 10.
num percentile 10. So num percentile 10. So if we do division with 10, we'll get the reminder as this number. So out of this we got 5 for the first. What should I do with this 5? What is our concept here?
Sum
Right? So that means
of all the digits.
definitely we have to take some initial sum. So that means once we found the reminder, what should we do with that reminder?
Sum plus or equal to rem.
Plus or equal to. After that, what should we do next? This is the first time we have done. Second time, after finishing that, what should we do? We have found the first digit, last digit of the number, then found the sum. Now this is the number.
Num percentile 10.
1 percentile 10 will give you what?
2. No.
How will
Num
it be?
percentile 100.
So, how many times will you, how will I count? You can see the division. 125 divided by 10. What did we get
Mm,
exactly?
Num divided by
10.
10.
Yeah, division by 12 will get the quotient as this one. Okay, because remainder is given as 5, but the quotient is 12. Yeah. So now I'm interested in what? Now do I need 125 or I'm interested only in 12?
12.
So I can trim off the number. I want to reduce the number to what? From 125 to 12. So to do that, what should we do?
Divide.
125 should be divided by 10. That's it. So that means now we have to do division of the number. So I will take the number and divide it by 10. Okay. Now we have come to the second iteration. In second iteration, what again we are trying to do? Am I repeating the same?
Yeah.
Yes.
So this is the repetitive procedure. How many times we should do this? That means this is what is the repetitive procedure.
Till number becomes 0.
Yes, so that's how the concept. So the condition here, that means while, now I can take while loop. See, for loop also because it will be more, see, this is blank and we are saying that as long as num is not equal to 0, and what are we changing with the number? We can do that anyhow, we can do Now, what should be there inside the loop? What are we doing inside the loop? First, what should we find out?
Num percentile 10.
So, first we have to find the num percentile 10. What should we do with this? This
We
is
should
Rem.
put it in a variable.
Yeah, if you want, you can take a variable. Otherwise, we can skip that step also to reduce the number of variables. So, if you want, you can take this. It's optional. But if you don't want, you can skip this. Ultimately, what you want to do with this remainder?
Sum plus
Sum.
or equal.
So, that
Yeah.
means once you found the remainder, next step was summing of the sum plus equal to remainder. So instead of these two steps, I could have written directly saying that sum plus equal to.
Rem. Num percentile 10.
So did I reduce one variable here? So I can
Yeah.
skip this. So this is a better program in terms of variable reduction. So next, what should we do after? Is there anything or it's only division? Sum of the
Division.
last digit and then changing the number. Checking is the number 0. If it's not 0, again find the last digit of the given number and then reducing it. Is that the 3 steps you are doing? We are finding the
Yeah.
remainder, then after that summing up the remainder, then changing the number. Again finding the new remainder, summing up and changing the number. This process goes till the number becomes 0.
0.
So this is the whole. Or else we can use a while loop which is more simple because it's a simple concept here. While num is not equal to 0 or greater than 0. Anything you can write. And just you can say sum plus equal to num mod of 10. Anything is fine, whatever is comfortable. Yeah. Okay. Is it clear to you? Any confusion?
Yes. No.
Now, if I say find the reverse of a given number, these are very known programs, but you should be very clear with the concepts. Now, if I have to find the reverse of a digit, so what is the logic in this part? If this is the number, okay, step by step. What is the first reverse digit in that? If I want to reverse the digit, what is the first digit in the reverse number?
5.
5.
What is the next? Okay, after that, what is the next? If I want to read two digits again, two reverse
2.
numbers. Two reverse numbers.
2 1.
Last two, from the last. If I say what is the last one reverse number, so it is last two digits in the reverse number.
5 2.
Last three digits in the reverse number.
5 2 1.
Just is there any difference? Do you find some logic here or not? Just outside. Is there any logic going on that 5 becomes 52, 52 becomes 521? Whatever the number may be, we don't know. Whatever the number may be, it applies the same. If it is 2, 3, 5, 6, something. So first take is 6, 65. You see some logic here. How this number 6 has become. See, you can get the digit 6 out of that number. No? You know how to get the last digit out of the number. If any number
Getting
is
the last.
given, yeah, getting the last digit already you have an idea. First number is already known. How did we get the last two digits? Like whatever it may be, I should get initially I got the last digit. And when you read this one, what does it look like? What is the change in previous number and second number? It is just 6. How do we read this number?
65.
65. Can I say 5 once and 6 tens?
Into 10.
6 tens. This is only 6 ones. Right? Again, same thing what happened here. Just check here. Something is happening here.
We're dividing the last number, multiplying it with 10, and adding the next digit.
Yes. Yeah. After that, the whole number is again multiplied with 10. Previous answer into 10 is, see, the first number was 6. 6 into 10 is 60.
60.
And then we add the
Plus
remainder.
5.
Now 65 is the new number, new reverse of the number. Take that number and multiply with 10. So it will become 650. And to that, what should we add?
3.
3. So it goes on. 653 into 10 is 6530. Here I can. So then 600 and 500, sorry, 6530 plus the next. Can you tell this whole code right now? What the logic here? You have to find the remainder. Take that remainder and multiply with
10.
10. Just try, give a try. So already there is a number given by the user. So whatever it may be, you accept from the user. And we have to find what right now? Like a sum, like the factorial. Now we have to find out reverse because we don't have an idea. So in sum of digits, what did we take initial sum value?
0.
0. For the factorial, what did we take the factorial?
1.
1.
For the reverse, what should we take?
0.
0.
Now just check the formula. How do we do that? We have to repeat this procedure till 1. Till 1 we have to repeat this. I started with the last digit till 1. Whatever we are going to do, how many times we have to repeat? Initially the number is 2356. Second time the number is reduced to 235. Third time the number is reduced to, last the number is reduced to
0.
Okay, I'll stop. Stop at this. So that means the same like your reverse of the digits. No? We are picking up one by one the digits out of that. So you know the digits is nothing but remainder process, right? Once we get the digit, we can reduce the number by 10, division of 10. So this procedure should repeat till which? What is the criteria? How long this procedure should repeat?
Num not equal to 0.
Equal to 0.
And what we have to do in this first? What should we find first in this?
Num percentile 10.
Yeah, num percentile. Just let me take a variable for your understanding. Yeah? So we thought there is a reminder. So we have taken a reminder initial. Once we found the reminder, what should we do with that?
Rem into 10.
Into 10. Okay. Then what should I say with it?
Rem.
Again, then you should get a clue here itself. Just see. Okay, if I expand this, it is just 6 into, it's just 6 number. Second time it is 6 into 10 plus 5. If I write the expansion of it. If I'm writing it in expansion format, we got this expression To express this, I just wrote it is 6 ones. So I placed in this position. But this part is missing. But in the second point, I had 6 multiplied by, the previous answer was multiplied by 10. So that we got the tens position as 60. And what did we add to it? 5 ones. So you know how to get 5 out of the remaining. Third line. How will we do the third line? This answer is what? This is nothing but 65. Now third time what should we take? 65 multiplied by what? 10. And what should be added to this? Which number? The current last digit. You have to think a little bit on this, you'll understand. First, see, formulas are already there, we have done that. Now the new reverse number is 653. Take that reverse number and multiply that with what number? 10. And then what should we add to that? So at last we got this. That means we are getting these numbers only based on a formula. So what is that formula? Repeatedly, here we have something multiplied with 10 plus some number. In the second line also, something is multiplied with 10 and adding some last digit. Something is multiplied with 10 plus some. But only the first line, the similarity is missing. What is missing here? The plus symbol is missing. What is missing here? Can you fill this blank? What should be there? There should be some multiplication. What should be
1.
the... So that means what I am trying to multiply here. The right side is understood. Second digit is what? 10. It should be multiplied with what here?
0.
Okay. So already we saved 0 into which variable? 0 as which variable? Initially the reverse was 0.
0.
So I can multiply this with which value? Reverse value. So reverse into 10 plus the remainder is updated as what? New reverse value. So every time we are finding out the reverse only. Every time we are finding the new reverse by taking the older reverse into 10 plus the remainder. So just we have to understand that we have already initialized the reverse value. I need to just multiply. I'm trying to find which value? Reverse value by taking the product of the reverse into 10. And what should we add to this?
Num divided or equal to 10. No, num divided with 10.
What are we adding to this? This is reverse into 10 plus what is this number? How did we get 6 out of the whole number? If this is the number, how did we get 6?
Percentile 10.
That's reminder. That means we have added this to remainder. This is the formula, nothing more than that. So we are just finding the reverse through reverse into 10 plus the remainder. So if you want to save the variable, that means the variables, we can directly put a num mod of 10. And after that, we are just trying to reduce the number by division with 10. So now we get the new number. Now that means 2356 is reduced to 235. So again you check. Is it not equal to 0? Yes, 235 is not equal to 0. Again we'll repeat. So first reverse was 6 here. 6 into 10, 60. 60 plus new number, that is 235 mod of 3. So that will give us 5. So 60 plus 5 will get us 65. Then the number is reduced from 235 to 23. Now again do the same thing. So here the reverse was, already we had the reverse as 65. Now 65 into 10, 659, 53, 650. Then we get the remainder. So this procedure is same. Okay, is that clear? Any
Yes.
confusion thing here?
No.
No, ma'am.
I think I wanted to ask, like, would you be comfortable at 6 o'clock also?
Yeah.
6 also is
Yeah.
fine.
Yeah.
There's
Yeah.
another batch actually, so they were asking for 7 o'clock, 7:15 like that. So I'll start your class at 6 from tomorrow, 6 o'clock, 6 to
Okay.
7:15. Right? So any doubt till here?
No.
No.
Now you write a program, take the question and just find me the solution for it. Write a program to find out reverse of a given number. Sorry, palindrome. Find out whether the given number is palindrome or not. Find out whether the given number is palindrome or not. So I'll give you 5 minutes. Variable should be same. You should not change it. Variable name should be same. You write it, write the program in whatever compiler you like, and just show me the output. And we are using while loop. Right? So just you have to find out the given number is palindrome. Hello.
Yes, ma'am.
Yeah, did you finish?
Yes, ma'am.
Yeah.
Can you just share the screen? Yeah. Concept is same, no? There's no difference. Only after the logic, we have to check is it prime.
Yes.
So did you get the output? Correct output?
I
Yeah.
did.
Okay. This should be output. Let's share your screen.
I logged in from my phone and I did it in my laptop.
Okay, okay. You
Yes,
just take
ma'am.
a pic,
Same.
take a pic and send to the WhatsApp. No issue. You got the
Okay.
output, just send the output
Ye-
picture.
Okay.
Can you just find out a program which can find out the LCM of a given number? This you have to try. I think I'll give you again 5 minutes. But if you want, you can discuss the logic. You can discuss the logic here. Because after that, I anyhow the session will be closed. So if there is any number, one number, just okay, prime factorization. Just think, you want to do the prime factorization of one number. We'll just start with a prime number. So, okay, I think we didn't do the prime number concept before. Did you do the program of the prime number?
Yes,
You know that?
Yes.
Okay, can you tell the solution? How to check whether the given number is a prime or not? So
ma'am.
what is the logic for it? Actual logic is what, right?
If num modulus I equal 0,
No, not the program, logic. Just generally if I have to say, how do we say a given number is prime or not prime? What is the logic?
if it is not divisible, if it is divisible by any other number other than 1 and the number itself, it's not a prime.
Yeah, any number other than one itself. It's not a prime. It's a prime. How do we represent programming? It's also about divisibility test, no? Like factors. Factors.
Yeah.
Yes.
So I have to check, do we have a factor for this? Simply say if it has factor, has any factors other than which numbers?
One
1
and
and
itself.
itself. So we should just stop immediately and say it's not a prime number. So that means we have to just say that it's not a prime number. The concept is same in the representation. You're looking for the factors. If you have a factor, should I divide by 1? Should I check a numbers divisibility test with 1 and itself, or we should skip it?
Skip.
Yeah, so we're not dividing. So we are starting division from which number?
2.
If it's equal to 0, is it true or false right now?
True.
True. So what should we do next? Should I go for further division? Should I further check for the other factors? Or since it got one factor, we'll stop immediately.
Break and
But
find the
Yes.
factor.
That means now it's a factor, so we break here also. Once the factor is found. If in this position I've taken 9, will it be a factor right now?
No.
So if it is not a factor, I'm doing something else. If it's divisible, I'll just break it. If it's not divisible, what am I trying to do?
The loop continues.
Yeah, so repeat the same number by. Next procedure is same. We are dividing each the number by each number starting from 2 onwards till less than the number. And wherever it is divisible perfectly. So in this scenario, first was false. So I just went to the next iteration. I just took this to the next iteration. And we did the same thing again and we found divisible. This is true. So what should we do when it is divisible?
We should break.
So that means we are doing two things. If it's not divisible, what are we doing? And if it is divisible, what are we doing? If it's not divisible, what should we do? And if it is divisible, what are we trying to do?
If it is not divisible, we should try with the next number.
That means we have to just go for the next one. Correct? But
Yeah.
if it's divisible,
We have to break.
Break.
now in the loop we'll only do these two things. Means I'll check if it's divisible, I'll just write this code. Divisible, break code. But how will I decide it's a prime or not? The loop is written properly starting from 2 to the number. The loop will be starting from which number?
2.
2. Till which number?
Less than or equal to the number.
Should I go
And
till the number or before the number we should stop? That means we should be just checking till the less than the number. Should I divide just with the last number or the number also? If I say equal to, it will do the division with the number also.
less than the number.
Yes, so it's important. And we are going to just move on in which iteration? Is that clear? So here we have written the initialization test expression and I plus plus is written. So already we said whenever it is not divisible, what we are trying to do? I plus plus. So it is already written here. So do I have to write the code for not divisibility or only divisibility?
Divisibility.
So if the number is divisible, what should I do?
Break.
Now still we have to take a decision. What is the decision? Whether it's prime or not. How can I say it's a prime or not? Based on what? I started the division test. If it's a prime, let us take few examples. Now if the number is 7, where will the loop break? If the number is 5, where will the loop break? And if the number is 13, where will the loop break? Same way, if the number is 12, where is the loop break? I'm taking all non-prime numbers at once. Just these are all non-prime numbers. So when I took the number 12, when did the loop break? I said whenever it is divisible, we break. But which count of 5 we broke the loop for the number?
2.
For the 9, what was the number that we broke?
3.
And
5.
for the prime numbers, when did the loop break actually? Did it break in the middle somewhere?
No.
So what the loop had to start at this number? When did the loop break exactly? Prime number 5 divided by 2 divided by 3 divided by 4. I less than number. When I reach to 5, should I do division or did I stop at that? Did I do the division with the number also or less than the number?
Than the number.
Yeah, then
So when it's a prime number, the loop has broken at which number? When we
Less
reach to
than.
the number. When we reach to the number, the loop broke. 4.
Mm.
5 was divided by 4. But was 5 divided by 5 also?
No.
no.
No. So that means when the I reaches to the number, we are not doing division. When the iteration reaches to the number, already we stopped. Because I say all those I values which are less than the number should follow into the divisibility test. We are not going to enter into the loop When we reach to which number? This current number. Number 5, number 10, whatever. So if I reaches to the number, we are not going to do division because anyhow they are divisible. Number will be divisible by number itself. So if we have taken a prime number, iteration stopped at which number? The number was 7. We stopped at which number? What was the I value at that time?
7.
Yes. So for the 5,
5.
5.
for 13 it is 30. Can you see something is there in this? These are the three solutions to say that it's a prime number. Not prime. When can I say it's a prime number now? Can we decide on the I value?
I equal to n.
Yes. So if my I value is equal to the number, that means successfully there was no division. Because of that, it reached to the number. So it's a prime number. Otherwise, if it broke down in number two, definitely it's not a. Is that clear? Any confusion in this concept?
No, ma'am.
So generally in columns, the boy will be writing some counter variable, count plus plus. We take something like that. It's not required. We don't have to do count. Because already I is just working like a counter. If you stop in the middle, means it's not a prime. But if you stop at the number, it's a prime number. Simple concept. So we are not taking extra counting. So generally we say no. If count is 1, means if it has a factor, means it's not a prime. If count is 0, it's not a prime number. So we say something like that. We take an extra C variable. We don't need that count variable. Without that, we can just write a big condition for only divisibility. And mention that it's prime. So just tomorrow you tell me this program. Somebody of both of you to explain this. Find the LCM of or prime factorization. Let us show you this one. Prime factorization. What is it? It's 12. That we can do. So just have to write the prime factorization and 2 6 12 3 and just do the same division. Tell me this answer. So it's 6 and again it goes to 2 2 3. Prime factorization. This is what one it is 2 into 3. 3 that is prime factorization. So you can print this answer. I want to see the complete prime factorization of the given number. This is one thing. And next is LCM of two given numbers. Two given numbers. Okay. So any doubt in today's program?
No, ma'am.
So anything you can put a doubt in WhatsApp, no issues. Any new program you're learning. HackerRank, are you trying those questions? CodeChef for HackerRank. Did you register in HackerRank?
No.
Okay, today you do registration also. Just sign up in that. Try to solve the first question. You'll understand. Programs, the questions will be lengthy, statements will be more, but program is small only. Just try that today.
Okay.
One program that you just try today and see whether you are able to do it. Or else I'll show you maybe 1 or 2 days later. I'll show you the practice.